So for our Arduino code, we start by declaring a myServo object. We also include 4 integers to hold the values that we're going to be receiving from our sensors, and also a trigger integer, which will help us with communicating with processing and changing the stage. Down lower, we have a heartbeat variable. This is just going to determine the delay between the on and off of the heartbeat. And we also declare our input pins for all the sensors and assign them a number. We assign our heart to pin number 9, that's the heart LEDs, and we set our left and right eye LEDs to pin 4 and pin 3. In our setup block, we start by setting the baud rate for the Arduino, which is again going to help us communicate with processing. And we also set the pin mode for all of our digital pins, which include the heart, the 2 eyes, and also our touch sensor, which is a digital sensor. We attach the servo and we also send it to an angle of 130 in order to get our 90-degree leg movement. So this was how it start in the downwards position. Down in our loop, we assign the value from the sensor to the variable. We just declared it up here. And so we do that for all of our analog ones as well as our digital one. So value light 1 is going to be the analog reading from the first light sensor. Val light 2 is going to be the analog reading from the second light sensor. Val temperature is the analog reading from the temperature sensor. And val force, which is called val force because we were previously using a force sensor, will be the value from the touch sensor, which is either 0 or 1. We took the value and divided by 4 because the light sensors are going to return a number up to 1023, and we want it 255 for the LEDs. Down lower we have sort of our triggers for what happens when the sensors get activated. So we have 2 identical ones here essentially, which pretty much require a certain amount of light to be shined into each sensor in order for the light to light up. And after it lights up, which you can see with the digital writes, it changes the value of trigger to a certain number, which will be sent over to processing in order to change the screens. Down lower for the heartbeat, similar sort of thing. We have 3 stages for the heartbeat, depending on the temperature. So as the robot slowly gets warmed up, the heartbeat will beat faster and faster. And once it reaches its peak warm-up point, it changes the trigger variable, and that impacts processing. This is what is actually triggering the LEDs to go on and off, and you can see the delay, which takes heartbeat as a parameter. Now our final sensor and our final sort of reaction to the human user is the servo, and that pretty much just determines if the touch sensor is touched, is going to move the servo to a degree of 40 through a delay of 300 milliseconds and then back to its original position, as well as triggering the next stage. And down here, this is what kind of ties it all together, is the printing to the serial monitor so that processing can see what stage we're at. And that's our code for the Arduino.
Okay, so our processing code essentially provides the graphical interface that the user interacts with on the laptop next to the robot man. So as you can see, in our first 2 lines of our processing code, we imported the processing serial library and also declared a serial port. Now this will be used later on to establish a serial connection with the Arduino code. Over here in Void Setup, since all of our prompt screens are images that we created in Adobe Illustrator, here in Setup, I'm just initializing the images so they can be used later on. Here, I'm just opening and initializing the serial port in order to establish a serial connection. So this is the same port that Arduino is using, and 9600 is our baud rate. So here in Void Draw, we decided to use cases to switch between the different prompt screens. So case 1 is the start screen that users will see when they approach the toy, and once they click the button that says, I can fix you, this will trigger the change to state 2. Now state 2 is our intro screen, and this provides the backstory for the toy and also contains a start button. And the clicking of this button will trigger the change to state 3. In state 3, this is the first screen that provides a prompt for the user. As you can see in the Arduino code, once the user has followed the prompt and the sensor has reached its desired value, this will cause the trigger integer to change. Now back over here in the processing code, the trigger value is being read, and if the incoming byte that is being read equals 49, which is the ASCII equivalent of the number 1, then the state will change. And this is how we were able to use the user's actions to trigger the next prompt screen once they had completed the task. Now we use this for all the prompt screens, and that is our processing code.